Hi, everyone, and welcome to the DREDGEPACK software webinar featuring the new reporting tools. Before we begin, I just want to remind you about the question box on the side of your screen. We will be taking questions at the end of the webinar, so please submit them using the question drop-down box. Our presenters for today's presentation are Cristhian Bermudez and Thelen Pumford of HYPACK Technical Support, and they're going to be guiding you through the new reporting tools in DREDGEPACK, which are designed to make analyzing dredging data faster, more accurate, and easier than ever. Follow along as they walk you through these powerful new capabilities that will enhance your projects. We're very excited to have them here with us today. And with that, I'm going to turn over the presentation to Cristhian and Thelen.
Hi, everyone. This is Cristhian. A quick introduction. I've been working for HYPACK for almost 10 years now in the technical support department. And right now I'm leading the DREDGEPACK product definition in HYPACK.
Hey guys, this is Thelen. I'll just introduce myself real quick. I've been working at HYPACK for the last 2 years, just over 2 years now. Before that, I worked for a few different dredging companies as a field and production engineer, so running surveys, calculating volumes, and tracking job progress. And that's just to say that we think we've identified some things that we can do at HYPACK to help the dredging industry in their day-to-day operations. And that's what we're here to talk about today. So with that, I'll pass it back to Cristhian.
All right. Dredging is a demanding and resource-heavy process where accuracy, efficiency, and planning often decide whether a project succeeds or falls short. So most of the companies recognize the value of a strong execution, but the challenges are multiple and many still face critical gaps. So having a holistic visibility of what is happening during the operation is crucial. So understanding the challenges and pain points within organizations is essential to choosing the right tools that truly reduce the burden on both operators and managers. In this presentation, we will walk you through the key aspects, the common struggles and maturity levels that we see across the dredging organizations, the technologies available today that can directly address these problems, and finally the value proposition that HYPACK brings as a solution provider. So starting with the operational pain points, the operators work differently. Some operators take wider swings, others take shorter swings. So making production rates inconsistent, so that creates an issue because it is hard to compare the performance. So in the same way, the downtime, how the downtime is logged, can be problematic if the description is not very clear. So for the managers and the on-site engineers, it is hard to determine if the issue was a mechanical issue or if it was an operational issue. So without having a standardized monitoring, the visibility is lost. Specific information about the position of the dredge, the material, how it was removed, how not having all of that information tracked properly cannot be used as a baseline to measure the performance. So additionally, the planning, companies sometimes assume the standard equipment will be enough, but when the material turns out compact, or let's say it is a harder material, removing it is more complicated, so it slows the operation. So additionally, poor planning sometimes leads to failure during the project. The timelines, basically, there is an assumption that the progress is going to be steady, but harder material or modifications in the plan requires adjusting the whole operation. So finally, sometimes the historical data that is generated during an operation is not recorded properly, and that information cannot be used for for a future project. Several projects face poor visibility during the execution, so the managers usually don't only see the pre-dredge and post-dredge information. So the daily production problems or a daily definition of the production is not presented properly. So sometimes that information is hidden until the project ends. And if it's like that, it's hard to make a decision and adjust certain things during the operation. So sometimes critical events between surveys, they are go unrecorded. Let's say there you have a core head that clogs twice during the day. If that information is not logged properly, it is not possible to know it is the whole operation is getting less progress than expected. So the data can also it is not always used to help the new operators. When the data is not recorded, it cannot be used for training the operator or understanding the good practices or the good approach. So the opportunities for improvement are missed. An operational issue is not analyzed properly, so it cannot be used as a learning lesson. So in certain cases, the knowledge stays siloed. So probably there is a good operator, but he's the only one that understands how the maneuver can be executed. And that information is not transferred properly. So in the same way, the companies have some issues having their retrospectives, trying to understand what was executed properly and what the things that need to be adjusted. So on the other hand, we have the data management pain points. So it is hard to have a centralized point for receiving the information. In several cases, the underperformance is often discovered too late. So a dredge may remove far less material than planned, but management only finds out that weeks later when the reports are finalized. And in the same way, understanding the workloads, how the equipment is used, is something that it sometimes is not collected properly. So in a sense, the issues aren't cocked in time. Just for example, if you have a booster pump that is not working properly, that information can be unnoticed for days or weeks, and that affects the whole operation. So the centralizing data is crucial. As it is right now, the industry has several manual tools. Important records are sometimes lost. For example, a supervisor might log a pump downtime on paper, or if the sheet is misplaced, that downtime never appears in the analysis, leaving gaps in the data. So in some cases there is Excel spreadsheet, so it creates different versions of the information related to the operation. So different engineers can access to the same as Excel spreadsheet, creating different versions, and basically that could create some conflicts in the calculations. So as a result, the insights are could be delayed or basically can be corrupted because of that. Additionally, for the equipment, when there is a new equipment installed, these upgrades often go unmeasured. So let's say if the dredging company has a high capacity pump, but if the company doesn't record how the performance was before and after installing the new equipment, it is impossible to determine if it's really helping. Of course, then in several cases, it is the companies can really see an increase in the performance, but it is not possible to give sometimes numbers or specific details of that. And in the same way, what the companies want to have is the proper return of investment these solutions are implemented. And finally, when the whole operation it is optimized and basically that would be translated into a better planning that again is translated into a more efficiency in order to use some resources. So these are the main pain points that there are more. We just wanted to bring some of them so you can connect the pain points to the solution that we are offering. So I have the demo one. I'm going to show some of the tools that we are bringing with DREDGEPACK. So just to start pretty quick, I'm going to jump into the hardware configuration to show only a couple of details that we are going to have in DREDGEPACK. So the first part is we are improving the whole user experience with all different drivers in order to simplify the way you can configure the drivers and also bring in additional tools that can enhance the calibration. So in this case, we are very focused on the reports and the information that can be generated from the dredge, and that's why I'm going to cover only this tab. So we are including some additional tools in the drivers that make possible to organize a structure of the different downtime or delays that can be during the operation. So this is important because it is something that the operator can have available in the driver, and also the on-site engineers can have some other tools in order to classify or provide more description of what's happening during the operation. So if the dredge is not pumping or is not operating, classifying or explaining why it is crucial. So here is only you can see only an example. This is something that can configured at different levels, providing codes and having some other possibilities. So I'm going to jump into DREDGEPACK so we all understand better what the operator will see. So here I have the core suction driver that where we integrated additional tools, as I mentioned before, for improving the whole user experience, where the information is presented in a different way, bringing multiple options in order to configure different parameters and simplify how this profile view is presented for the operator. And here you see two additional options on the top. So if the dredge is operating properly, let me basically adjust my simulator so we can see a better example. Let me only select a line file here that I used just to simulate a new cut. So it is presenting a new cut. So let's say my dredge is operating properly. So I lower ladder and I make it swing automatically. So it will remove material. So if it's removable material, I can press the pumping option. So as it is right now, what it's doing DREDGEPACK, it is recording the information and is making that information available and organized on a structure that provides basically a better organization of the data and simplifies the way you generate reports. We are going to cover that in this webinar. So there are additional tools that we are working right now, and that's pretty much what you see here. So this is a program that is collecting information from DREDGEPACK and is organizing the whole definition that comes from the sensors. So the raw information from the sensors, position, heading, and all possible variables that you can have, for example, in a core suction dredge, density, vacuum pressure, all of those parameters are recorded, are properly organized. And this program allows the users to configure and define different parameters in order to save the data in a different way. So I'm going to show you here under settings. I can configure, I can generate a new configuration. Let's say I am working in a new project, so I can put a new project name. And a new project ID, for example, the expected volume to be removed. And in the same way, I can classify the data, bring in, for example, some equipment. That's something that I presented before. So let's say I just want to know what is the performance before we start, we install the booster pump, and after we install the booster pump. So the data can be classified, and that's the main goal, is not only storing data, the data needs to have a proper structure in order to be used properly during the basically the reports. So this program is showing some information. It does some calculations for the operator. The different gauges and parameters can be changed here. So the calculations, it could be estimated material removed, or if the dredge has the sensors, the specific sensors for, let's say, a density and a flow meter, it could show the information that comes from that sensors in order to show the production. Here it is showing the runtime, and let me explain that a little bit about the downtime and the runtime. So if I go back to DREDGEPACK, I'm going to simulate. We are not dredging. I'm going to raise the ladder, and then I'm going to press delay because we are not dredging. And here we want to classify, and the idea is that it is important to give more explanation of why the dredge is not removing material. So, but we are including two sections here. The users can use the normal standard codes from the DQM, or they can use their own codes under the user-defined tab, where, for example, let's say the dredge is not operating right now, it is not removed material because there is an electrical issue. I can add some nodes if I want, but if I press OK here, now the dredge is in delay, and in the program that monitors the operation, it is saying the whole operation is delayed. So that information again goes to the database that saves all of the information, and it will be available for their reports. But this dashboard shows the data in real time. So additionally to what we are having here, I'm going to present some other things. But this is pretty much what the operator can see, and there are some additional tools that we are covering. We are going to be covering. So let me go back to the slides. So as it is right now, now you should be able to understand a little bit more about the different challenges that are in the different organizations. And basically, we are trying to define the whole solution in HYPACK that it is connected to different levels of maturity in the organization. So there are companies that we define this the level one, the companies that are reactive. So companies that are not really using data in order to improve the operation. Those companies only have the dredge. Probably they are using DREDGEPACK, or in some cases they are not using any program like DREDGEPACK. They go to the field, they remove material. So there is a level two, is where the companies are using part of the information, part of the metrics and insights in order to make some decisions, in order to adjust the operation. Level three is when a company has a very well organized structure for the whole data that comes from the operation, and that information is used all the time to make decisions and basically to adjust the operation. And the last part is the higher level, is the optimization, is when the companies not only use the data, but that information is serves a different purpose in order to optimize not specifically or not only the dredging operation, but some other parts in the organization, some other processes in the organization. So in terms of or connected to all of these aspects, I have that we have identified there are different technologies, and we are basically offering different technologies to improve the operations. So starting from the data collection or data capture using sensors, interfaces, and I already mentioned a little bit about the digital lever log, where you can basically provide more description of what's happening during the operation, giving a structure for the data, having a database, presenting the information in an organized way. That information then goes to the visualization and summarization. So it is instead of seeing the raw value from the sensor, it's possible to see the translated information that is translated to insights or metrics. And finally, using the data, at some point, it would be possible to generate forecasting and simulations. And of course, in that sense, having the solutions from the machine learning and artificial intelligence is crucial. And so I have this second demo for you. And so as I mentioned before in the pain point, sometimes seeing what's happening during the operation is hard. So we are incorporating some additional tools that basically allows DREDGEPACK to not only structure the data, but have the data ready in order to upload that information to the cloud and have a solution pretty much what you are seeing here. So let's say you are anywhere in the world and you have a computer or a tablet, so you should be able to see the information from the dredge. So in this example, I'm showing some polygons that represent the area covered by the dredge, but I can also see the patterns of the whole swing. So it is possible to see how the dredge is performing, if it's getting the enough width of the swing, if it's progressing properly. So everything is time tagged, so it is possible to see some other parts of the operation. And additionally, it is important to mention that what we are trying to present here is the intelligence that you can extract from the data. So you see some metrics associated in order to determine if the swing speed is correct, the area that the dredge is covering during the day, it is basically compliant to the expectations. It's the same thing for the volume. So the dashboard is pretty much showing that information. So on the right, as part of the intelligence, it is not only important to know how the dredge is operating, but it's also important to know what is causing a delay. And that's what you see on the right. It is possible to list the different causes of delay, and it is also possible to see if the whole runtime is compliant to the expected performance. So in this case, it's showing 74%. So if that's the performance defined by the company, the company should be able to monitor this properly. So the idea with these solutions, it is having them available anywhere in the world. So I'm presenting here something from my phone. Let me connect my phone. So if you have a dashboard configured as it is, you can even monitor the operation from your phone and you can understand what's happening. So that's the pretty much what I'm going to cover up to this point, and let me hand this over to Thelen.
Okay, hopefully you can see my screen now. So we kind of wanted to show you guys a real life situation, and we were lucky enough to have a company provide us with some of their information about a project. So we've gotten their surveys, their BD and AD surveys, some background charts, and the data and a database from the monitor program that Cristhian just showed you. So a little bit about this project, just to give you some background on it. This is one of the areas that they will be digging in. Actually, this is an ongoing project, so they are currently still working on this project. So just to show you this little area, it's about, if you look at the bottom of my screen here, it's about 100 meters wide and about a kilometer long. Okay, So it's a simple rectangular shape, and really this is an ideal scenario if you want to really figure out what the best digging conditions are for your project. You can do, or for your dredge really. So you can do a bunch of different things, changing swing widths or ladder elevations, especially due to the fact that there's plenty of material here. There's no real channel coming through the middle that's splitting this cut area in two, so you don't have to worry about swinging too wide and not actually getting any material because the template or the material is going below the template. So really an ideal situation. And what they've done here is they separated this area into 4 25-meter wide cuts, and they began their work progress last month, and they're still currently working on it right now. Again, we're lucky enough to have some of this data. And there's a few different areas that they have. So this is area 1. There's a few different areas downstream. So we're hoping that some of the data that we collect can be used to improve some of their operations downstream later down the road. So just to show you some of the cross sections here, we have got quite a bit of material. They're digging down to 1.8 meters. Their over depth is down to 2.1 meters. And if I scroll through some of the cross sections, we can see there's quite a bit of material for them to dig through. And in total, they have around 210,000 cubic meters to dig through. So quite a bit. This dredge, I know it's fairly large. So I think it was around 300 feet or so, 100 meters, I believe. Don't know the exact specifications of the dredge, but anyways, there's a lot of material here, and they've decided to separate it into 4 cuts. So we've got their monitored database, okay, and some of the things we can do with that. I'll open up this page here, so we can kind of create these production reports, right? So we've got this production report here that's showing me this one on the left here, showing me the downtime and runtime of each day. And if you see here, some of the days actually don't have, they weren't using the monitor program exactly correctly, which is something we expected. They're pretty new to this, and I think it's their first time using DREDGEPACK. So they weren't quite using it correctly at first, but you can see as the days go on, the blue represents the runtime, the gray represents the downtime. Ideally, we want those to equal 24 hours if this is a 24-hour operation. So we can see a few different things in this graph. Obviously, again, some of the days they weren't using it quite correctly. And if we scroll down into the table here, we can actually see how much downtime and work hours, runtime they had for each day. So again, some of the days don't quite add up to 24 hours, but we're still getting some good information out of it. On the right-hand side, we've got a similar graph. This is showing us the daily pay cubic yards and the daily gross cubic yards that they're achieving on a daily basis. So we can see that they're doing pretty good some days, and other days they did not so good, whether it be to run time diminished for some reasons, and then we also see this large gap in here. But another important thing to look at is we've got this red line that's showing us their target cubic yards per day, and that's an accumulated target cubic yards per day. This black line here is what they actually accumulated. So every day their cubic yards is increasing that they've removed. And at first they're really doing well. And then again, we have this long period of downtime or repair days that they saw. So it's about a month of downtime, and I'm not exactly sure why they were down during this time. But if they knew about some repair that might need to happen, before the project, maybe they should have made this this repair before the project. That way, you know, their estimate or they don't start having their accumulated cubic yards go under this this red line here. So just a cool little graph that we can show. And maybe it's something that an engineer can show to their manager and say, hey, look, maybe we should have done something differently here. Maybe before we started this project, we should have made these repairs, so we're not having to move the dredge out on site, move it back to a shipyard to make this major repair, and just have some data that backs that that thought process up. And we can also see down here, we also see the total pay in more of a table format that shows us how we're doing here, and each day we can see the accumulated pay as well compared to their project estimate. So these are the kind of things that we can get from the database if you're using it correctly. There's more things that we can show for sure, but this is, you know, kind of a main ticker in a report that I would like to see. And if we want to actually dive a little deeper into some of the daily operations, we can do that. I'll move on over to this other graph that we've got here, or dashboard report. So on the left-hand side, I've got the heading of the dredge with the other axis as time. Okay, so we can see if you see this green start, this is marking the start of a swing, and this red triangle is starting the end of a swing. And it's going, you see, we're ending one and then starting one basically right after, which is what we want. Okay. We also see some flat periods here where the dredge was not changing any heading. So, you know, that's most likely going to be a downtime. And we see, you know, a few of those coming, or a few of those within this little report. We can also see how they were swinging over here. If we think that they're swinging okay, we can see that. If we don't, we maybe can suggest to the operator or talk to them and see what was going on. But one thing I noticed quickly, just from creating these reports here, was the average duration of each swing, which obviously this is still including some downtimes here, but this is quite a long time to be swinging from one side of the cut to another. So we've got our average decreasing and increasing swing here. So that's just to say increasing would, it's the increasing heading and decreasing heading, or, you know, your forward swing or your back swing, depending on which way, you know, your cutter head is swinging. So obviously this is quite a long downtime. And actually, if I scroll down a bit, we can see that the first index, it's index 0, this one right here, this swing, the duration that it took to get from one side to the other was almost 7 minutes, which again is quite a long time. And I might be asking some questions on why it took that long. And I know from talking with this company that they were seeing some hard sand, some clay in their cut. And you know, if that's something that's really going to delay us for the rest of the project, maybe there are some things that we can do about that, whether it be changing the cutter head or making some other kind of changes to the cut or how deep we're digging. Those are some things that we can look at, and it's nice to have this data here in a way that actually shows us what's going on. And at some point, if we've made the tags that Cristhian mentioned, you know, with the booster pump, one of the tags that we could add in this situation was maybe we change the cutter head to a cutter head that's designed more for tearing up the harder packed compacted sand material, and then we can use that tag to then compare the differences of before and after we change that cutter head, and we can see if our average decreasing and increasing swings kind of changed any. Another interesting thing to see here is that, so the first swing took 6.97 minutes. The second swing took around, about 2 minutes longer. So one swing is taking a little bit longer, and we can kind of see that throughout the swings here, which is, might be interesting just to take a look at. But one thing that we thought about during looking at this data set here was, what if, this is a rather large dredge. So what if instead of swinging or making your cuts 25 meters, we make our cuts 33 meters, which doing that in a 100-foot wide or 100-meter wide cut, I should say, would decrease the amount of cuts. So if my dredge can handle 33-meter cuts, what would it look like versus a 25-meter wide cut? So we kind of did some comparisons or a little simulation doing that, and what we came up with was just using swing speed. So if the swing speed stays the same at both cut widths, the cycle time for a 25-meter cut, meaning how long it takes to swing one direction, then how long it takes to swing the other direction, was 7.5 minutes. The cycle time for 33-meter wide cut was 9.9 minutes. And then we've got our estimated advance per hour, our daily advance at 25 and our daily advance at 33. So obviously we're making less advance per day, but our cut's a little bit wider. So, we should be covering around the same amount of area, or maybe even more if we're operating very well. So we've also got our days per cut at 25 meters. Again, this is about a 1 kilometer length cut. So we're saying it might take 4 days to complete this cut. It might take 33 days to complete the 33-meter long cut. But then the interesting thing that we saw was the days to complete just using swing speed was slightly lower than our days to complete at 25 meters. And that's not including the number of moves you have. So, once you finish a cut, you're gonna have to move the dredge, right? So we're just saying that maybe it takes 4 hours to move the dredge back, set everything back up, and continue digging again. That could decrease your days to complete at 33 meters even more, because you are having to move the dredge less as well. So these are the kind of things that we are really trying to organize and give you guys an opportunity to look at in a way that's more structured, right? So I spent a lot of time taking handwritten lever logs and putting them into Excel and making reports that way. But the more times you're passing handwritten logs and data back and forth and putting it into different programs, that kind of introduces some areas for data loss. So using the tools that we are trying to incorporate into HYPACK, we're hoping that we can make better reports for our customers to then create or run their projects, make better decisions, and ultimately make more money at the end of the day. So we can also show the map here if we wanted to show where they were this particular day. We can print these as a PDF if we wanted to show our managers, send them out as an email, what have you. We can also change the days we want to look at. So if I wanted to look at day 7, we could change and recompute the date here. So we can see, again, we've got our swings here. The duration this day was, or our average duration was a little bit better, but still 8, 7 minutes, 5 minutes. To me, that's still pretty slow. So they were definitely seeing some issues with the with hard packed material. So anyways, that's kind of some of the things that we're trying to do and help customers make these reports and make better decisions. So with that, I think I'll hand it back to Cristhian, and I will stop showing my screen here And there you go.
All right. Thank you, Thelen, for presentation. Okay, so just to summarize a little bit what we just presented, we wanted to highlight that HYPACK is offering an end-to-end ecosystem that it starts from the dredge, and it provides tools that can be used in the office in order to bring that intelligence to the operation, and in order to have those valuable insights in order to improve certain aspects. So I just want to explain these dredging operations life cycle, so you will understand how we are transforming the definition of DREDGEPACK in order to give these new tools. So starting from the planning, when you are designing a dredge plan, whether it's a channel design or cut areas, so DREDGEPACK offers that, and that information then it is used in real time for the operator. So we are bringing all of the tools and improving the whole experience in order to make the DREDGEPACK show the proper information and help the operator in real time. That information is stored and organized in a proper structure, so it is available to generate or see the data in order to obtain some metrics, insights, understand patterns, understand the performance, defining KPIs. So when the information is showing that part, it is possible to generate reports as Thelen presented for, summaries. So the information is classified in different ways. So the operator, the on-site engineers, they see the information probably with high detail, understanding what's really happening with the swing. But for the managers, it's important to see the high level report. So that's something that we are also incorporating. All of these, the idea is to have what I presented before, the web monitoring, so you can monitor your asset and in order to the proper asset management. So anywhere in the world, you can see what's happening. You can understand if some modifications in the whole operation are required. And finally, the last part what I'm presenting here is how all of these things connected and together provide a business intelligence in the dredging operation. So this is where the companies can do the strategic analysis and can transform all of those insights, metrics, data, reports into something that modifies the way the operation is executed. And that's why it's important to mention that the final step here in the business intelligence box that I have here, it represents a cycle. Because once you have information, you can use that information in order to do another planning and start the whole cycle again. So this is the definition that we are having right now for our DREDGEPACK, and this is pretty much what you are going to expect in the future development. I would say it's pretty much that. Thanks so much.
Thank you, Cristhian and Thelen. That was a great presentation. I just want to share with everyone who is still on that we have exciting news. Our registration is open for our HYPACK 2026 training event, where you can learn even more about these tools that we're talking about, our HYPACK software packages, and all the features coming in 2026. It will take place on January 12th to the 15th in New Orleans. So go register, and we hope to see you there. And next up, we have our Q&A section. We are going to try to answer all your questions, but if anyone's goes unanswered, we will follow up with you via email over the next few days.
Okay, so we received a question that says, if DREDGEPACK is closed, will the monitor program log at that time as downtime as long as HYPACK is still open? The monitor program is a standalone program. It's designed designed to operate independently. So the idea is to have a program that can track the information from the operation and organize data. So the user basically can interact with that program without having a DREDGEPACK open. We have some other questions here. It is, how much will these tools cost? Basically, part of what we presented here is going to be connected to the licenses that several companies have, and sometimes it will require modifying or having a different type of license. That's something that we are adjusting and organizing for the users. And as you saw, there are some other tools like the web interface, and the information is considered software as a service. So it would be a subscription where the users can access to the data using the web browser. So we have another question here is, will the companies have access to the database to make reports or dashboards? Initially, as we presented, the tools that we are offering include the reporting tools in order to not only store the data, but also generate reports out of the data. So I would say at some point the same report program can even export part of the data or data in certain ways, so the users can do a different report. Let's say they want to do a different calculation in Excel, so they should be able to do that. We have another one. Related to the web dashboard that I presented, is how often this dashboard updates the data. Basically, the dashboard is receiving, or the cloud solution is receiving an update in a configurable time. For example, it updates data every 15 minutes. So the information can be available with some delay, but again, the dashboard is designed for providing like a quick summary of what's happening during the operation. It is not designed for like a real-time visualization, pretty much the way DREDGEPACK works. So it will have some a small latency, but it will upload the information, and as long as the information is uploaded there, it will generate a new version of the dashboard, and it will basically show the new widgets updated. I would say we have another. Okay, it seems that's pretty much the questions.
Okay.
Yeah.
So I want to thank everyone for joining us today, and we want to make sure, Cristhian, can you go to the next slide? Perfect. So we just want to remind you guys, you can visit our YouTube channel for videos about software and new features. And don't forget to sign up for our newsletter. That's where the latest things come out, and you'll be up to date with them. And also check out our website. We do have some upcoming virtual trainings as well as our big training event. So thank you so much for your participation today, and we hope you enjoyed the webinar. Everyone will get a copy of this presentation through email in the next couple of days, so that way you can watch the on-demand recording or share it with anyone who couldn't make it. And we will get in touch with everyone who had unanswered questions over the next week. Thank you so much.